Hi guys, welcome to Code While, and today again we're back again with another lead code question called counting bits. It's basically an easy level question in lead code. And yeah, before we start the question, I want you to read the question once. I hope you have read the question. So basically, they're saying they have given an integer n. You have to return an array answer of length n plus 1 such that answer of I is the number of ones in the binary representation. For example, if there are two numbers, so in two numbers, the indexing is starting from 0th. So 0, 1, 2. So what are the number of ones in 0, 1, and 2 in the binary form? So it's represented as in 0 we know that there is no 1, so we get 0. In 1 there is 1 binary bit, in 2 there is 1, so output will be 0 1 1. For 5, let's take an example. Let's take a paint for the better understanding. So for example, if the number is 5, so what will be the index from 1 0 1 2 3 4 and 5, right? So for 0, the binary form will be in the form of 0 itself. There is no ones in this. So what will be for 1? So for 1 as a representation will be 1. For 2, the representation will be 1 0, right? For 3, it will be 1 1. For 4, it is 1 0 0, right? For 5, it will be 1 0 1. So what are the number of ones in this? For 0, the number of 1 is 0. For 1, it is 1. For 2, it is 1. For 2, for 3, it is 2. For 4, it is 1. For 5, it is 2. Right. This will be our answer. Right. So yeah, that's what it's given here. 0 1 1 2 1 2. Right. 0 1 1 2 1 2. Cool. So basically, how can we solve this? We are going to see two approaches today by which we can solve this. First, let's go on with the first approach. First approach is bit simple. It is using the approach using the built-in function called built-in pop count. uh, I don't know if you are aware of it. What it does is, for example, if the value is 2, for 2, the binary form will be 1, 0, right? So what built-in popcorn does is, it returns the number of ones present in the number, right? That's it. That's what it does. I mean, it directly gives us the value. For example, if the value is 3, what are the number of ones in the binary form? It returns the a value of it. That is the function of built-in count. Let me code you so that it will be more clear. Let's take a vector for storing. You can take an array as well, and just just run a for loop which is starting from 0, because we need from the indexing from the 0, n and I plus plus, and we just say that we dot push back. Now what we do, as we discussed, will use a built-in function called built-in pop count of I. What it does, as I said, it returns the number of ones present in the binary for representation of I. Well, let's return this. Let's see what do we get. If we return v, see, we are getting the binary form. Directly we are just using one built-in function and you are getting the answer itself, right? It's crazy. If you are taking 5 also, you'll get the answer. It just returns the number of ones in the binary representation of y, so we get the answer. We are submitting this, it accepts. Yeah, it does work, right? Can you do it in other approach? Yeah, we can do it in other approaches in more optimized way, that is using DP. So using DP, how can we do this? Let's see that. Yeah, now let's go on with the DP approach. I mean, how the approach is taken. For example, I have already took the values from 0 to 8 and its representation. Can you say that if A of n is an even number, then A of n by 2 will also have the same binary bit value? I mean, the number of ones in both A of n and A of n by 2 will be same. Can you figure out that one? For example, let's take 4. What is the binary? I mean, the number of ones in the binary value, that is 1. What is 4 by 2, that is 2? Is the number of ones in both the values same? Yes, it is same. But yeah, we are not convinced till now. Let's try with other example. Let's take 6. What is 6 by 2? That is 3. What is the binary value? I mean, the number of ones in the binary value, it is 2. What is the number of ones in this binary value? That is 2 again. But how is this happening? Let's see it again. Basically, what is happening is, we know that every representation takes place, I mean, the bit a value changes in the form of 2 power I, right? Right. What do I mean by this? 2 power I. Like, for example, if you are just taking 2, it is representation is 1 0. That is 2 power 0 place you get 0, and 2 power 1 place you get 1. What happens in 4? You get 1 0 0, right? So that is 2 power, in 2 power 2 place you are just getting 1 value. So that is pretty much clear that the other values, I mean, in other places you don't get the value, right? I mean, let's take another example for more clarity. If you're taking 3, it is 1 1. That is 2 plus 1. Can you say it? Because 1 is in the form of 2 power 0, 2 is in the form of 2 power 1. That is 3. What happens in 6? That is 1 1 0. That is 4 plus 2, right? You are just shifting the bit by 2. You are just shifting the bit by 2. It was 2 or 3 was like this. You are just adding a 0 at the end to make it 6, right? Nothing but you're just shifting the position, you're not shifting the bit, right? I mean, you're shifting the bit, but the number of value or number of ones in the bit doesn't change, right? That's the same thing what we are up that's the same concept we are applying here. But okay, now we are convinced with even number. What about odd numbers? Now let's see for an odd number. Now, can you say that every consecutive bit differs by 1? For example, if you're taking 4 and 5, what is for binary representation? That is 1 0 0. What is the binary representation of 5? 1 0 1. Can you say that only at the place of ones, because 4 plus 1 is 5, right? So it pretty much says that only at the one place you add one, right? That is at 2 power 0, that is one place you get one for one bit. So it's pretty much clear that between two any numbers, like if it's a even number, between 4 and 5, the the addition of one value will be for sure, right. So can you say that, you can say that uh, for example, if you're taking n, if n is an odd number, can you say that a of n equal to a of n minus 1 plus 1? Yes, I can say that, right? But can you observe something? Can you observe something? What is that something? This is odd, right? This is odd. So obviously, if you are taking this as n as odd, n minus 1 will be even, right? N minus 1 will be even, right? So what do you know? What do you know if it is an even number? You know that if it is an even number, you can replace it by a of n by 2, right? Can we apply the same thing on this? Yes, we can apply. So can we write a of n as a of n by 2 uh, plus 1? Yeah, we can do it. We can just ignore n minus 1 because it just, as I mean, it does give you flow value itself, right? So nothing to worry about that. So can you say this? Yes, we can do it. So now our problem is pretty much solved, right? Yeah, it is pretty much solved. So yeah, we are just using the same concept in this, and let's just solve it. So yeah, just take it as just treating till n and I plus plus, and we are just saying that if I double v of I is equal, if it is even, if I mod 2 double equal to 0, then it is a of v of I equal to v of I by 2, else else it is v of I equal to v of I by 2 plus 1. Sorry, it starts with 1. So if it is starting from 1, we need to specify v of 0 as 0, right? But yeah, before that we have to reassign this. Uh, Sorry, it is resize, right? I forgot. And plus, and I think now it should work. Let's just try, and we have to return v. Let's run. Should work. It does work. Let's submit. Yeah. So yeah, this was the DP approach, and That's what, like, DP approach is nothing but you're just breaking the big problem into sub problem and you're trying to optimize it, right? Just that's the same thing what we are doing here. So yeah, that is pretty much it. See you in the next video. If you like the content, do like the video and subscribe to the channel. As I mentioned, there are a lot more contents which are going to drop from the channel. So yeah, uh, be safe and keep coding. Thank you.